Alright, this is the video for homework 1119, extra credit for Math 1 Honors, but a graded assignment for regular Math 1. I'd like you to write down this work. Everything that you see me write down, I would like you to write down. These problems already done for you. It's up to you if you want to write those, but copy all the work I'm about to write to get full credit or extra credit. So in this problem, I want you to add 800 to both sides, which will cancel that away and gives you 2,187 equals 3 to the x power. To solve for that unknown variable, we're going to use the log buttons on our calculator. You're going to log the big number without the x, 2187, put your parentheses around it, divided by log of 3, the smaller number attached to the base, and that should give you 7. So 3 to the 7th, 2187 minus 800 gives you 1387. All right, back to these. You need to know that this first set, you're going down by 3, subtracting by 3. So going up, you're doing the opposite. You're adding 3. So that zero term, 10 plus 3 gives me 13 for that zero term when I'm using it for my explicit. The recursive form is f of x equals f of x minus 1 minus that number you're subtracting as you're going down. Don't put the plus 3, the one going down, minus 3. That is recursive. The explicit form is using that slope, negative 3, putting that in front of x, and adding or subtracting that y-intercept term, which is going to be plus 13 for this one. Or I could use that negative 3 times, in parentheses, x minus 1 plus the first term 10, realizing that these are equivalent. Even though these look different, they are the same. This one will give you negative 3x plus 3, and that plus 3 and 10, 13. These are the same. They look different, but they are equivalent. This is negative 3x plus 13 in disguise. All right, for the geometric, this is timesing by 3, timesing by 3. That is my common ratio number. If I'm going up, I'm timesing by the reciprocal of 1/3 or dividing by 3. So my zero term, 2 times 1/3 gives me 2/3. So my explicit form recursive form for our geometric is f of x minus 1 times that number as you're going down, timesing 3. That's recursive. The explicit would be f of x equals either the zero term, 2/3 times 3 to the x. So again, explicit, the zero term, 2/3 times that common ratio raised to the x power, or I could multiply by the first term, which is 2. That's the same as 2 times 3 to the x minus 1 power. Those are equivalent. Alright, so know that there's going to be one of those on Thursday. There's going to be a logarithmic problem on Thursday. Know those. No recursive, no explicit, no arithmetic, no geometric. Alright, for this table here, the domain measured from the left boundary to the right boundary looks like rounded bracket because that open circle on -5 to positive infinity. I know it looks like it's going down, but domain measured left to right, that's going to the right. So -5, positive infinity, rounded. For my range, because this arrow is going down, this is not the bottom of my data. My data goes down here forever. So there is no bottom to it. That is negative infinity up to positive 3. These inequalities are just what we call set notation. Another way of describing this. Math 1 students, don't worry about set notation right here. My maximum would be the very highest point right here, which is 3, 3. My minimum would be none, because this arrow going down, there is no minimum. Don't be faked out. That is not the minimum. Minimum is none or does not apply. All right, 2 more. Number 5 or 4. I'm sorry. Back to this increasing. As you're going left to right, if you go uphill, that's increasing. So the only stretch left to right going uphill is this stretch right here, bordered from -3 to +3. So square bracket -3 to +3 square bracket. Set notation, that would be -3 less than or equal to x less than or equal to 3, matching these. My decreasing, as you're coming left to right, that would be going downhill left to right. I got 2 sections left to right going downhill, measured from -5 rounded to -3 square, and then also from 3 square to positive infinity, not negative infinity, positive, because you're going to the right. Set notation, -5 less than x less than or equal to -3, 3 less than or equal to x less than infinity. Again, Math 1, you only have to worry about interval notation. Math 1 honors, you'll be doing interval and set notation. All right, so interval and these are set. Don't mix those up. Okay, for number 4, where these two are equal is where they intersect. So that would be the point 2, 2. Write it as a coordinate. The next one, interval where g of x, the g line, is above the f of x line. The stretch where that g line is on top is right here. Border from left to this right number right here. So from -infinity to the left to +2, square bracket, because this is more than or equal to. If that would have been a regular more than, this would have been rounded, but more than or equal to, square bracket. Set notation, -infinity less than x less than or equal to 2. That's where the g line is on top. Where g of x is less than f of x, that's the spot where the g line is underneath. Bordered from 2, round bracket, because that inequality, to positive infinity to the right. Don't put negative infinity. Where f of 3, that means find 3 on the x-axis, go up until you hit that f line and write that number. So there's 3 on the x-axis. Go up, hit that f of x line, look over. That value is 4 right there. Minus g of 1, go to 1 on the x-axis. Go up until you hit the line I'm looking for, the g line. That would be 3. So 4 minus 3 gives me 1 right there. So these are me giving you the x values. You find what the corresponding y value is. The next problem has me give you the y number. So don't go to the x numbers like these. Go to the y number, which is +1 on the y-axis. If I could erase that. So +1 on the y-axis. Hit that line, the g line you're looking for, and then look down and give me that x number. That would be 3. Okay, I want you to graph both these and then graph h of x. So that first line here, starting at +4, going over 1 down 4, that is the equation -1x for going over 1 down 1. My slope is -1, +4 for my y-intercept. My f of x line starts here at -2, over 1, up 2, over 1, up 2. You should be able to see that that y-intercept of -2 with that slope of 2 over 1, that equation is 2x minus 2. I will change that, I promise. So the h of x line, is g of x plus h of x. So I'm going to replace that f of x and g of x. I'm going to replace those equations right there where those used to be, and I'm going to combine like terms. So when I replace it, g of x gets replaced with negative 1x plus 4. F of x gets replaced with 2x minus 2, and I will fix that. That's minus 2. So that when I combine negative 1x plus 2x gives me positive 1x. 4 minus 2 gives me 2. That has a y-intercept of positive 2 over 1 up 1 over 1 up 1 over 1 up 1. Draw that second line or that third line. Draw your line through it. I'm going to label that h of x equals 1x plus 2. That is the equation with these two equations working together or against each other. Alright, last one. This one, domain and range from a table. So domain are from left to right, your x numbers. So for Math 1, don't worry about this open section. Just go straight left to right from negative 1 square to positive 7 square. That's my domain from left to right. My range are these numbers up on top, these y numbers, from the smallest of them, negative 20, to the biggest, 12. So again, don't go left to right. For range, it's the smallest to the highest, negative 20 to 12. My maximum is the biggest f of x or y value. I could see my maximum, my highest y value is this 12 right here. So if I write that as a complete coordinate, that's negative 1 for x, 12 for y. My minimum is the lowest y value up there. I could see that's negative 20. So that point would be 7 comma negative 20. That is my minimum, my lowest. So the highest, look for the highest y value. The minimum, look for the lowest y value. X-intercept for this, to review, the x-intercept is where you have y is 0. The y-intercept is where you have x is 0. So the x-intercept would be 2 for x, 0 for f of x or y. And the y-intercept would be 0 for x, 8 for f of x or y. And again, review, x-intercept, the y-coordinate is 0. The y-intercept, the x-coordinate is 0. So those are my x-intercepts, y-intercepts. For Math 1, this is all you need to do. For Math 1 Honors, I want you to break this up. That is a split. That negative 12 is an open section. That means you have a line that's going like this. If I could draw it. Oh, it's not going to let me. But that has an open section. So 2 separate domains, 2 separate ranges. So my first domain at that split would be from this negative 1 to 5. So my domain for Math 1 Honors with this split from negative 1 to the open section round on 5, and from 5 to square 7. Write that in set notation, negative 1 less than or equal to x less than 5, 5 more than or less than x less than or equal to 7. My range has that same split from the lowest negative 20 square to negative 12 rounded, and from negative 12 rounded to positive 12 square. And that in set notation, negative 20 less than or equal to y less than negative 12, negative 12 less than y less than or equal to positive 12. So again, for Math 1, write all this work. Math 1 Honors, write all this work to get your extra credit. Good luck.